Consider a frictionless, massless and leak-proof plug blocking a rectangular hole of diameter 2r into L at the bottom of the open tank as shown in the figure. The head of the plug has the shape of a semi-cylinder of radius r. The tank is filled with a liquid of density ρ up to the tip of the plug. The gravitational acceleration is g. Neglect the effect of the atmospheric pressure. The force F required to hold the plug in its position is the vertical hydrostatic force F in vertical direction. So let's say Fy will be given by rho g into V, where V is the volume. Now the important thing here is to find out which volume we will consider for the calculation of this F. So if we, let's just say, if we make this control volume here like this, let's say this is point A, B, C and D, and let's say this point B, point A. So the volume V here, capital V, this volume is, so volume of the fluid in this section, in section A, D, E, C and B, above this curved surface. So let me write here volume of fluid above the curved surface. So the volume we can calculate by this volume can be calculated by the volume of cube. So let's write Vc for that minus the volume of this hemisphere. So Vh. Okay, so this will be equal to, and the volume of cube will be, this is height r into 2r into L, because 2r into L is the dimension of a rectangular hole, right? Minus, and it is given in the problem actually, minus the volume of hemisphere, which is pi r square by 2 into L. Okay, so from here we can write the volume will be 2r square into L, 1 minus pi by 4, right? So this is the required volume to calculate this force, the volume of this section. Let me hash it here. Okay, so this yellow hash section, we got the volume 2r square into L into 1 minus pi by 4. Now Fy, the vertical force in hydrostatic force in vertical direction, will be equal to density into acceleration due to gravity into this volume. So we can write 2r square L into rho into g into 1 minus pi by 4. Okay, so from here we can see that option A is the correct choice. To get more information on hydrostatic force, you can refer to the NPTEL course lecture number 5, Measurement of Pressure and Hydrostatic Force on Fluid Mechanics by Professor S. Datta of the Department of Civil Engineering at IIT Guwahati.